Alright. I'm going to change the order of materials a little bit from the syllabus. The next thing we should be looking at is the proofs with the sets. I think that's a little more involved, and I would like to be with you in person where we can stop and start a little more easily. So I'm going to go ahead to the next section where we're talking about functions. You all know what functions are. You've had pre-calculus. So we are going to talk about functions and inverse functions. So we know that a function passes the vertical line test. So in order to have an inverse function, so inverse functions require a function to be one-to-one in order to exist. So if we would like to prove a function is one-to-one, we will use the definition. The definition of a function is that for each x, there is at most one y. So for a one-to-one function, it also has an addition. For each y, there is one x. So that would be the vertical and the horizontal line test. And, let's write it out, and the horizontal line test. There's that and, it has to be both. So it has to pass the vertical one to be a function and the horizontal one to be a one-to-one function. Alright, so the idea is if the y's are the same, if y's are equal, then x's are equal. So the way that we write that is if f of a equals f of b for some numbers a and b, then, so I'm going to write implies a equals b. So if y, this is really another name for y, right? So if this y equals this y, then the x's that I plugged in for them must be equal. So this is how we write a proof of function being one-to-one. So let's look at an example. F of x equals 2x plus 3. We all know what that looks like. That it's a line going through 3 with a slope of 2. So by looking at the graph, I think it's pretty clear that it is a one-to-one function. But we want to prove it one-to-one using this method. So we're going to assume that f of a equals f of b. Well, what is f of a? 2a plus 3. And what is f of b? 2b plus 3. So how are we going to get to a equals b? We're going to use the regular rules of algebra, which tell us we can subtract 3 from both sides, leaving us with 2a equals 2b. And then next, what can we do? We can divide both sides by 2, giving us a equals b. Therefore, we have just proven that f of x equals 2x plus 3 is one-to-one. Now you might be thinking, well, is that going to happen all the time? Why wouldn't that happen with every function? Well, let's take one that we know it doesn't work. Let's try x squared. We know x squared is the parabola whose vertex is 0, 0, and it's clearly not one-to-one. So what happens if we try to prove it to be 1-to-1. Okay, well, let's see. Let's assume. So assume f of a equals f of b. So then x squared, except if I put a in there, that means a squared equals b squared. Well, how am I going to solve for a? To take the square root. But remember, when we take the square root of both sides, what do we always have to include? Plus or minus. So assuming these are the principal square roots, I get a equals plus or minus b. Well, technically it's the absolute value of a and the absolute value of b. But the point is, notice whatever a is, then this one's going to be the b and the minus b. So I'm not proving that a equals b. I'm saying a equals either b or b's opposite. Equals b or its opposite. So that's a problem. That's not 1-to-1. How can I disprove 1-to-1? The way that we disprove something is called a counterexample. We want to disprove something, we find a counterexample. So here's a counterexample. F of 2 equals f of negative 2. Because what is f of 2? 2 squared and negative 2 squared. 4 equals 4, but remember the opposite of a true statement of if-then is the if, so f of a equals f of b, but a not equal to b, or a not necessarily equal to b. It may happen to be, but it's not having to be. So 2 is not equal to negative 2 in this counterexample. Okay, let's look at another one. Let's look at the square root. So if I have f of x equals the square root of 2x plus 3 minus 5, what does that look like? Well, remember from our pre-calculus, then it moves it over to the left, squishes it up, and moves it down. So it's going to look something like that. It's going to be 1-to-1. We could put it in our calculator if we wanted to, but let's just go ahead and look at how we're going to prove it. Let's assume square root of 2a plus 3, I should say f of a is f of b. So 2b plus 3 minus 5. Of course, I'll add 5 to both sides, getting the radicals to be the same. And then, what am I going to do? Square both sides, giving me the radicands to be the same, 2a plus 3. And then I can subtract 3 from both, and I can get 2a equals 2b, divide by the 2's, and a equals b. Alright, let's look at one more. Let's look at a hyperbola like 2x plus 3 over 4x plus 5. Well, again, if you remember from pre-calculus, what do you know? You know that there is a horizontal asymptote. These are the same degree, so at 2 over 4 or 1/2. So you have this horizontal one. You know that the domain excludes negative 5/4, and the way it excludes negative 5/4 is with a vertical asymptote. It goes through 3/5, and you know these asymptotes, it approaches them but never touches them. The x-intercept is negative 3/2. So it appears like it would be 1-to-1. It certainly passes the vertical line test, y is solved for, and it appears that it's going to pass the horizontal line test. So let's prove 1-to-1. Okay, so we're going to start by assuming f of a equals f of b. So 2a plus 3 over 4a plus 5 equals, now let's put the b in, 2b plus 3 over 4b plus 5. Alright, what can we do? Well, we can multiply both sides by the LCD. So what is the LCD? 4a plus 5 times 4b plus 5. 4a plus 5, 4b plus 5. Notice it's the same result as the so-called cross multiplying. So 4b plus 5 times 2a plus 3, and 2b plus 3 times 4a plus 5. Now we get to do some algebra here, distributing, or what some people call foiling. 4b times 2a is 8ab. 4b times 3 is 12b. 5 times 2a is 10a. And 5 times 3 is 15. 2b times 4a is 8. ab. 2b times 5 is 10b. 3 times 4a is 12a. And 3 times 5 is 15. Notice I have 8ab on both sides, and I have 15 on both sides, so I can subtract those away, getting 12b plus 10a equals 10b plus 12a. Well, let's get the a's and b's on the same side. So let's subtract 12b from both sides, and let's subtract 12a from both sides. So I'm doing the same to both sides, so I can do that. Notice the 12b and the minus 12b give me nothing. 10 minus 12a is negative 2a. And when I add these together, I get negative 2b. And I'm going to divide both sides by negative 2, leaving me with a equals b. So there proved it 1-to-1. Just in case you've forgotten, how do you find the inverse? Remember, you swap the x and y, and then you solve for the new y. And remember also, when you find the inverse, f of x and f inverse, that when you compose them, you get x. So you can actually find them, which is something you'll do in your project. So see the handout for the project. And as far as that project, you should be able to, at this point, to begin looking at it And some of it we haven't gone over all of the material for, so you won't be able to do all of it yet. But notice when you look at it that there are 6 questions. So 6 questions. You choose just one from each of the 6. Let me perhaps move this down. Okay. Ones you can begin on. You are ready, I should say, to look at. Would be number 2, which would follow with what we just did. Looking at the inverse, how do you know? Well, you know it has one by proving it 1 to 1. So that's what you're going to do with these, is you're going to prove they're 1 to 1. Find their inverses. Number 1 we haven't begun working on yet. That's relations. Number 3 is induction, so we have not done that yet either. You could also look at number 4. Number 4 is the one that would require a graphing calculator unless you want to write a computer program. If you do write a computer program, you need to show the code and run the program and show its output as well. Okay, number 5 depends on what you want to do with number 5. So if you choose number 5(3), you could work on it. So that's the logic one. We haven't finished with the relations, so you couldn't do 5(1) and 2 yet. And then number 6 is the only one that needs to be typed. The only one needing to be typed. The others can be handwritten. So you want to look those up. Again, you don't want to just copy, plagiarize is the other word for those. The idea is we're just looking to see that you can write a paragraph about something or a couple of paragraphs about something that you've researched, and use good English and so forth. Okay, stay warm, stay safe, and hope to see you Monday.